Let's say that you want to create a PWM signal so that you can dim the brightness of your typical LED using a potentiometer, or monitor the voltage of your power source higher than the input voltage of your typical Arduino Uno. If so, you need to get familiar in ADC, or analog to digital converter. So in this video, I will be showing you how ADC works and how to work with them. Let's get started. So what is the ADC? An analog to digital converter, or ADC, is a very useful feature that converts an analog voltage to a digital number. Not every pin on a microcontroller has the ability to do analog to digital conversions. On Arduino board, these pins have A in front of their label, A0 through A5. Indicates this pin can read analog voltages. ADCs can vary greatly between microcontroller. The ADC on Arduino is a 10-bit ADC, meaning it has the ability to detect 1024 discrete analog levels. Some microcontrollers have 8-bit ADCs, or 256 discrete levels, and some have 16-bit ADCs, or 65,556 discrete level. The ADC reports arithmetic values. This means that the ADC assumes 5 volts is 1023, and anything less than 5 volts will be a ratio between 5 volts and 1023. The analog to digital conversions are dependent on the system voltage, because we predominantly use the 10-bit ADC of the Arduino on a 5-volt system. We can simplify the equation slightly. Let's have an example. Let's say that we have an analog voltage of 3.3 volts, and let's calculate for the ADC reading. We only just need to put the 3.3 volts in the formula just like this. Then, simplify the equation. Then, we can calculate that the ADC reading is around 675 discrete levels. So, I will be using the built-in 3.3 volts output of the Arduino board as the voltage source. So, let's plug in the Arduino and head to File, Examples, Basics, and then Analog Read Signal. Before uploading the sketch, you need to double check your board and ports, as always before uploading. Then, connect the analog pin 0 to 3.3 volts output of the Arduino, then open your serial monitor. You will see that the ADC reading is around 675 discrete level, as we calculated earlier. Next, add a male jumper wire in ground to read the ADC reading of the battery. In my case, is a 18650 battery. Connect the analog pin 0 to positive, then ground to negative. Then, if we look the serial monitor, it's around 835 discrete level. You can use this value to determine the battery voltage. Then, if we put the value in the formula earlier, you can see that the voltage is around 4.08 volts. In order to verify this voltage, head to File again, then Examples, Basics, then open the analog read voltage, and upload the example sketch. So, if we connect the battery again, we can see that the voltage is around 4.08 volts as we calculated earlier. But we are not done yet. We still did not created the very popular voltage divider to dim an LED, for example. So in Arduino IDE, I set the analog 0 as input and pin 9 as output. Then, I use the analog write function to pin 9 and map the analog 0 to convert the analog voltage into digital. Then, I set the duty cycle of pin 9 from 0 to 100% after making that code. Click Upload. I hope that you like this video. If so, don't forget to like, share, and subscribe, and hit the notification bell. Thank you so much for watching this video. Again, thank you, and I will see you next time.